Hello everyone and welcome to We Meet at Digital Days. My name is Marie-Therese Kohl and I will moderate this presentation. We are very pleased that you took the time to participate in our virtual conference. The topic of this presentation is Simple and Secure Cloud Connectivity Solution for IoT Applications. Our speakers are Aditya Madanahali and Miroslav Adamov. They will hold the presentation and will answer your questions. But before we start, I would like to point out one thing. You will be muted during the presentation. This means that you cannot ask questions via microphone during the presentation. But nevertheless, you have the opportunity to ask questions during the presentation at any time via the chat function. And you can find the chat function in the control panel. This presentation will be about 30 minutes long. The chat questions will be answered in a Q&A session following the webinar. And there are 5 to 10 minutes in addition scheduled for this. If we are unable to answer all of your questions within this time, we will answer them via email afterwards. And if you still have any other questions left, just mail us at exhibition@we-online.com and we will try to answer all of your questions promptly. At the end of the webinar, you will be asked to participate in a feedback survey. We would be pleased if you take the time to fill out the survey and help us to improve the event. You will receive the link to the presentation in the next few days, and the recording will be available at our website shortly. But now I will hand over to our two speakers, and I wish you an exciting presentation.
Hello, good afternoon, everyone. First, thank you very much for the introduction, Marie. And today, my name is Miroslav Adamov. Today, I'm with my colleague Aditya Madanahali sitting next to me, and today we'll try to explain to you what the easy and secure way to create an IoT solution, and so IoT application, and or to put it simple, how to easily come from the sensor to the cloud in a couple of easy steps. So
yeah, good afternoon from my side as well.
Sorry.
Yeah, sure. Yeah.
So
looking forward for the webinar today.
Yeah. So let's start. So first, today we're going to try to explain what is an IoT application, what are the constituents of an IoT application. We're going to give you a couple of words about wireless connectivity, and also a couple of words about the IoT cloud platforms in the IoT. So let's dive in. Ali, can you give us first a couple of words about the IoT application?
Yeah, sure. For IoT is kind of the word that is often very loosely used. I mean, it's more or less an umbrella term which encompasses a lot of domains. You have commercial, industrial, automotive. For different people, IoT might mean different things. You have smart industry, smart home, smart city. So, I mean, you might have seen, for example, you have some kind of a thermostat at home which you use to control the temperature, and so using Alexa, or this might be one of the applications. But yeah, like I said, IoT is kind of an umbrella term that encompasses a huge variety of applications. So, but simply put, any application which results in interconnection of devices over the internet, let's say, and results in production, transportation, as well as processing of data in order to obtain value-added services, can be categorized as an IoT application.
So if I understood correctly, so an IoT application, so you take your old stupid, let's call it stupid application, give it some kind of a sensors, data acquisition, wireless connectivity, and cloud at the end, and you get kind of a smart application.
Yes, that's correct. That's absolutely correct. Yeah, as you just spoke about the DOM application, I would call it the IoT Boost. So IoT Boost basically includes providing connectivity to get the data from the application into the cloud, into the IoT platform. So the basic question here is, why should we do this? So it's cool, of course. We are working on it. It's cool. So let's do it. But there is actually a lot of advantages that are to be had. So when we provided our customers with a view on a large amount of data of their devices, there were new insights that they gained into the process that run these applications.
Yes.
For example, you can optimize the processes, provide predictive maintenance, you have safety and security of the people involved in these processes. Of course, you can provide better quality improvement, and in the end, business improvement in general. So this is where IoT comes into light. Miro, can you just throw some light on what our customers told us with regard to IoT applications?
Yes, of course. As you already mentioned, we asked the customers a couple of questions. We made a couple of interviews with the customers, and like multiple questions. I chose two of the most important ones. First is how intensively you are dealing with the topics of the IoT, and how important is the IoT in your company compared to the other innovation topics. As then you see from the charts here, the customers are dealing intensely with the IoT topics, and the IoT topics is immensely important in like wide area of the different applications.
So it is no longer just innovation, but it's actually in practice.
It's in practice. Actually, it's in practice. So can you explain us how this actually works in the real time, in the real world?
So let's see. I mean, as any IoT application, as we discussed earlier, consists of sensor nodes. These are nodes which consist of sensors which physically measure the environment. So the data is measured and converted into digital format. So this digital data is then transmitted over the wireless link, usually to a gateway. So the main function of the gateway here is to accumulate the data and aggregate it, and then present it to the cloud over the IP connectivity. So this is the basic infrastructure or the basic architecture of an IoT system.
Okay, so put it simply, you have a node, you have a gateway, you have a cloud. That's an IoT system.
Yeah, sure.
Okay. But can you explain us how this actually it looks like? So
yeah, that's the thing. I mean, it seems to be really simple, but it is also a little bit complex. The complexity comes from the fact that you're dealing with a variety of domains of applications. So at the very low level, at the sensor nodes, you are dealing with embedded systems. So you have a microcontroller which controls or reads the sensors and controls the wireless connectivity. So in this domain, you're dealing with low power design, making the devices as small as possible, and the devices do not have so much processing power and so on. But as you move along the stack here, you end up with the cloud domain where you have completely different design considerations. Maybe you can throw light on what are the factors that affect the design in the cloud.
Well, in the cloud, you don't have this kind of problems because you have enough processing power. It's like there is no lack of the processing power, but the real challenge is how to make this application at the same time scalable, flexible, and secure. It's like that's the huge problems with. And our main goal is at the end to get kind of a data system or data information which can be used in the future to get machine learning, artificial intelligence, at the end predictive analytics or alarms and inform the customers about or the devices about the process. Yeah.
Okay. So moving on, let us break up the system and look up at these systems as individual components. Maybe I will start with the wireless connectivity. So wireless connectivity is a real essential part of an IoT system. Of course, you can connect the sensors with cables, but when you're talking about places, or for example, on a machine which is vibrating at, I don't know, so many hertz, and you want to connect a sensor to it, so there the flexibility and reachability offered by wireless connectivity plays a really important role. But what is the technology that is suitable for IoT applications? As it is often, there is no one single answer. So I would like to divide the communication into two categories. One which is suitable for nodes, where we deal with a very small amount of data. So let's say a couple of bytes per sensor or so. So if you use IP connectivity at that level, you'll be having a lot of overhead on the protocol itself. So you can go back to communication standards which have low throughput, but you need to be a little bit more energy efficient because these nodes can be battery operated. Mm-hmm. On the other hand, when you are connecting gateway to the cloud, you definitely need IP-based connectivity, for which you have to consider as much as possible. I mean, there are two basically available technologies, which is Wi-Fi or cellular. Exactly, cellular. So based on these compromises, you have to consider which is suitable for your application based on the range you want, based on the throughput you want, And of course, you also have to consider factors like security, local regulation, and so on and so forth.
So like multiple parameters in the same
Yes.
system.
What is happening of late is all these wireless connectivity standards are adapting themselves to be suitable to IoT. For example, the narrowband IoT standards of LTE is now specifically designed to have low overhead to transport small payloads over the cellular link. And this is similar in case of Wi-Fi.
Oh, okay.
I mean, this is a brief overview of wireless connectivity. Maybe we should look at the next component, which is the cloud.
Yeah. So, well, let's continue. So in the cloud, you have like a couple of essential components. I split this in 4, but that's like multiple, like hundreds of different services in the cloud. But in essence, you have like device management, which must be secure for the connection, because sometimes you need to do the over-the-air update and so on. So we need to be secure both ways. Also, you have the user management, so users need to have the access to it, and you have different users, different access levels. Also, the data needs to be stored somewhere, and on the data, you need to process this data. So you need to do something with like kind of artificial intelligence, machine learning, then predictive analytics, and also you need to inform machine if you control the machine, or the user if you have the alarms. Then you have like kind of a multiple levels of information. But yeah, so that's
yeah, this seems really logical. But I mean, when we talk about other technologies, we have something to see, we have hardware to see. Can you please throw a light on how it would look in a real world environment?
Well, yes. So as you can see, we chose like one of the main cloud providers, like with the biggest market share. I will not say the name, but you can see it on the screen. And if you look in this system, it's like very simple system with the device. Information coming from the device in the form of MQTT messages. Can be any other form of information, but we chose the MQTT messages, and it lands in the cloud in the IoT core in this case. And the IoT core is like kind of a storage for the information from the device.
Basically, the device management system.
The device management system,
exactly.
With the user management also. And then you have the rules when you create the rule when you send information to some service. And this service we can use, for example, the Lambda service. And for this Lambda service, then you can create different approach. You can go different directions.
So this is where you generate notifications and alarms and
yes.
so on. Yeah,
so for example, in this case, you have like a database stored with the alarm stored, and when the information from the sensor comes and say, okay, it's in the alarm area, that alarm will be created and will be sent to the SNS, like Amazon notification service, to the device of the customer. Also, you can send information through the data stream to the database. In this case, we are using the S3 buckets, just pure flat JSON documents, and then the end you have a visualization and analytics in the Amazon Click site. We can do the same thing with like different provider. What we already did, for example, this another big company, cloud company. It's the same approach. We have at the beginning you have like IoT device sending information in MQTT form. Then it lands to the IoT hub in the Microsoft, and then you can have different approaches. You can say, okay, I will send my information, say my information to the database, and then you can access it from your local Excel or whatever, so whatever your local file system. Or you can go to the stream analytics and then send the information to Power BI and do the analytics in the Power BI. Then after that, machine learning and artificial intelligence, whatever you want to do. Or you can just simply visualize your application and see the data on the screen, kind of a remote monitoring system.
So you have, in essence, a lot of services which you have to pick and choose in the right way in order to achieve your own application.
You have more than 100 different services we can use to create like your system, whatever you need to do.
Okay, that's really interesting. Let's move on, for example, to the next topic, which is really, really important. That is the IoT security. Yes. So based on the surveys we did, the most important topic that the customers or that the users are worried about is the security, because you get in the news every day, there is a data breach here, there is a device that is being compromised there. So most of the companies are hesitant to move towards IoT because of this IoT security topic.
Yes.
And why is the question that needs to be asked is, why is it so complicated? Because you have the security has been a topic for research and in use for tens of years,
yeah. For decades, yeah.
Yeah, but the thing is, we have been dealing with specific security things, but here you have a lot of different participants or domains which you are talking about. You have the user, you have the low-level sensor nodes where you talk about embedded security. So you have the physical security with the user, of course, and then you're talking about the data security at the cloud level. So there are several levels of security which needs to be taken care of. And like it was done previously, you can't think of security as an afterthought, which means that security of the whole end-to-end system has to be considered, which is a real big challenge in terms of IoT. So,
and then before you start creating your project.
Exactly. So security has to be taken care. I mean, there are a lot of regulations coming up. For example, from the ETSI, and there has been laws that is being currently considered in action. So this is currently a really happening topic, or the regulatory bodies are really looking into this. So you might have real IoT standards security very soon. So this is the current status.
That's very good. But can you tell us something about the prototyping? Because
yeah, I mean, we have had a lot of theory till now. Let's see. Yeah, exactly. Let us take an example here. So, I mean, this is a typical example which you find in any industrial application. So you have, for example, robots, as you can see here, working on a production line, and it is really essential that these robots do not have downtime, or you can minimize the downtime, which means downtime of the robot would mean the production stands still. So what we can typically do is mount sensors, for example, acceleration sensor, pressure sensor, and so on top of these robots, and make sure that the data is communicated to the cloud, where you can visualize it, as well as do additional things.
Yeah.
So this is the typical condition monitoring plus predictive maintenance application of IoT.
That sounds very good, but can you actually build a prototype?
Yeah, sure. I mean, the proposal here, what we are making here is to have the sensors from Würth Elektronik, the acceleration sensor, pressure, temperature, and humidity sensor connected to a microcontroller, which reads the data from the sensors and sends it wirelessly over the Calypso Wi-Fi module from Würth Elektronik. So the Calypso Wi-Fi module, it offers a secure connectivity to the cloud. So this is the system design. Basically, the next step would be, as you said, prototyping.
Prototyping, yeah.
So what is essential when we think about prototyping? The thing is, you need hardware which is really flexible, where you can get going quickly out of the box. So for which we have the FeatherWings from that we are offering from Würth Elektronik.
FeatherWings are open source standard.
Exactly. This is a part of the Adafruit Feather ecosystem. So you have around 160 to 180 boards that are available. You can pick and choose the boards, your sensors which you want, and build up a system very quickly, because these boards are easily stackable. So you need just a microcontroller board, and then you can pick and choose different boards as add-ons to these boards and
create a system.
Exactly, and which means you are really off the blocks very quickly. So
yeah, but
shortly said, these boards are excellent for prototyping.
Yeah, it's really the boards are really excellent for prototyping. So can you show us these boards which you are going to use today?
Yeah, we are going to use the sensor FeatherWing today. It consists of the pressure sensor, acceleration sensor, temperature sensor, and humidity sensor. And you also have the quick connector from SparkFun. So you can tap into the SparkFun ecosystem and plug in more sensors if you want to.
SparkFun has like more than 130 different sensors.
Exactly. So, and both the hardware and the software, as well as the documentation, elaborate documentation, is available on our GitHub page. So you can get started really quickly.
And it's open source, so it's free to download and free to use.
Exactly. We also use the Calypso FeatherWing, which consists of the Calypso Wi-Fi module. It offers a really good security features, a set of security features with secure boot, secure storage, and more importantly for this application, a secure connection to the cloud. Yeah.
So can you please give us an example then of the FeatherWing prototyping? So I mean, and also tell us what are the requirements to do, what you need to have to start the prototyping.
Yeah, I mean, it's really simple. You just need the hardware, which is easily available with the Feather format, and then we don't want to make the software really complex. So we have Visual Studio Code, which is really most popularly used, open source, also easy to download. And we have an extension called Platform IO, which is also really popular for embedded development.
Also open source and also free.
Exactly. And a set of really well-documented examples so that you can quickly get started.
Okay, sounds good.
So currently for this prototyping, as you can see, we have used the M0 Feather Express from Adafruit. This is a ARM Cortex M0 microcontroller with sensors FeatherWing and the Calypso Wi-Fi module. We connect, this is just for the USB power supply to the computer, and
it can be battery operated.
It can be battery operated with a LiPo battery, and send the data to Azure Cloud for today's demo at least. Yeah. And it can be easily visualized with the help of a dashboard.
Well, then let's start the demo.
Sure. Let's
show the
move to the
demonstration.
live demo. I would start with the FeatherWing repository on GitHub. As you can see, you have exclusive documentation of all the FeatherWings. I wouldn't go in detail about each FeatherWing. It would be, you can go through the website. And
today's technical presentation, just
let's skip it.
Skip the commercial part.
Exactly. So let's move on to the example, which, as you can see, there are examples for each and every FeatherWing. Today, we are focusing on sensor to cloud connectivity. As you can see, you have Microsoft Azure and Amazon AWS connectivity possible. We are focusing on Microsoft Azure
today. We are focusing on Microsoft Azure.
Exactly. So let me click on that.
So in Microsoft Azure, we have like multiple, as we showed previously slide, there's multiple approaches. What can be done? First, you need to create your IoT hub, and first, actually, you need to the account of Microsoft Azure, which is also free. You can create the IoT hub, and then create your devices. Actually, the shared device on the screen or device copy, and then there are multiple ways you can create the stream analytics job and visualize Power BI. You can create a database. Today we're going to show you how it looks like when you just connect like simple web application, which is also in a GitHub and can be downloaded for free. It's open source, and we're going to show you how it looks like to connect the IoT device to the IoT hub and IoT hub to the web application and visualize the values. That's pure remote monitoring, actually.
Yeah, as you can see, what I really find interesting or easy to do is follow the instructions step by step, because it's really hard to find such a description end to end to set up the whole process and also connect your device and see the values live. So I find this really interesting. So as you said, there are different approaches, and today we are focusing on the visualization part of it.
Yes.
As you can see, there is Power BI as well. So this is more towards artificial intelligence, machine learning, data analytics, and so on. But we are focusing today on
the pure remote monitoring.
Remote monitoring. Yeah, it's really important that we say that, there is also a free account possible on Microsoft Azure. Yes, but
the question is, if you want to do something like this, like stream analytics and then Power BI, it's can be very expensive.
Okay.
If you just simply do the remote monitoring, it can be free.
Okay.
Depends on the system. So it can be Microsoft or Amazon for that matter. If you do the simple services and not too much data for testing, can be completely free.
Okay.
So you can have the whole system free from starting with the open source code from both Elektronik till the cloud.
Yeah. And for those who are really not, for whom it is really not possible to go to the cloud, there is this option also to store in the local database and export it to Excel.
And then
that is also a really good way to start prototyping, because it's not always possible through the company network into the cloud.
Yes.
For which we also can be flexible and say you can
do this just locally. If you want, you can do the IO analytics completely locally.
Yeah, and what we are talking about today is then the visualization. So let me show the Visual Studio Code part. So the system is already up and running.
System is already up and running. I if you can see the system here, it's like 3 boards which are stacked in each other. 2 boards are from Elektronik. The third one is from Adafruit directly. It's Express so M0 Express Feather board, and 2 other boards like Calypso FeatherWing and Sensor FeatherWing.
Yeah. In the code, as you can see, the code is built to work with both Azure and AWS. I mean, we have to basically configure a few 4 to 5 parameters, that's it, from the cloud. So this is currently configured with our account, of course. All you have to do is configure these 5 parameters plus the local Wi-Fi network that is being used. So all this demo does is then initialize the Wi-Fi module basically and the sensors, provide a connection to the cloud, secure connection. So the interesting thing about Calypso is that you don't need to deal with the security certificates. Because of the secure storage on board, it has a root certificate catalog where it has already stored the certificates from Microsoft. So you don't have to load any certificate. Basically, it is ready to go out of the box. And all we do in the main loop is then read the data every second and transmit
Send it to the cloud.
Yeah, and that is what is happening in the logs here.
So maybe show the other side, how it looks in the cloud.
So now we can show the visualization of the cloud on the cloud side. So as you can see, you have the temperature, pressure, humidity, and the acceleration.
So I can try to show you how it actually works. So I'm just changing the acceleration on the, maybe I can touch it and change the temperature, find the temperature sensor, and then try to, yeah, you see
the temperature is
rising.
Yeah, and that's more or less a quick demonstration. I mean, this is a very simple visualization. Of course, you can do really a lot more with the data, right? I mean, you can, as we showed in the other slides. I mean, this is just the beginning.
This is just like a small scratch on the surface of the IoT, but it's easy way to show you how it actually works, and it's possible to in a few easy steps to get your data from the sensor over the gateway to the cloud in like a couple of easy steps.
Yeah.
So
not too many, not too much complexity with the hardware, not too much complexity with the software. This is a good way to start prototyping, see the data, get more insights,
and then you can get the ideas. If you see the data, you get the ideas. That's the point.
Yeah. Yep.
That's more or less everything what we prepared for today. So thank you very much, and thank you, Adi, for the excellent demonstration.
Yeah, thank you, Miro, for the insights today. I think now we'll stand by for the questions via the webinar.
So if you have any question, any ideas, or if you have the idea how to build the system, so please do not hesitate to contact us. Or you can contact us also directly.
Yes, thanks a lot to both of you. This was really interesting. As you already mentioned, we would like now to turn our attention to your questions. So feel free to enter them in the chat window, in the chat, in the control panel, and we will see what's coming in. Maybe one first question. You mentioned scalability, flexibility, and security of the system. Can you please elaborate on the security aspects?
Yes, for sure. I mean, security with respect to IoT has, like I said, has to be considered from end to end, from the sensor to the cloud. So what happens at the lower levels is that you have to consider the fact that your device has to be really secure, which means secure boot. Secure boot basically means only the firmware which is allowed which is verified by the manufacturer should be allowed to be run on the microcontroller. So that is where the security starts. Of course, you have to deal with the physical security itself, but the device is not in a place where it can be tampered with, of course. And then the next step would be to make sure that the data coming out of the sensor node is secure. So you have to think of the mechanism where you can encrypt the data coming out over the wireless link, and then the data once inside the cloud needs to be ensured that there is not just security but also the access to the data is controlled. So I mean, these are the basic, there are basic standards which are coming out. For example, ETSI EN 645 is the latest standard for consumer IoT devices, which is being currently ratified for the European Union. I mean, there are basic mechanisms. I mean, there are basic answers that are built in for here. For example, do not have default passwords. These are like basic security measures. Have make sure that your encryption is standardized. You don't use some obscure things, but you use real industry standard encryption. And what is the most complicated thing when you are dealing with non-IP based networks is then the key exchange mechanism. So this is some things which are, there are some kind of explanations given with respect to or basic standards that are being mentioned with respect to security.
Yeah, that's very complicated topic, but and can be elaborated a lot on this. So
thanks a lot. Maybe another question. Is it necessary to send the data to AWS Azure cloud?
No, we just take this as an example. We send data to the AWS or Azure, but you can send it to any cloud you want. You can send it to GCP or Alibaba or whatever cloud you want. You can also send it local. You can create your own local MQTT broker, and you can send it local. You can just send it to the syslog in your internal organization. You can send it to the database. So it's really open to do whatever you want. We have the example here because it's easy to do, and we just want to show that there is also possible to have the cloud at the end, but it's like open, and also our code is also open. So there is also an example in the code which we didn't show now, but in GitHub, if you download the GitHub, you can see the example with the MQTT broker itself. So
yeah, that is the advantage of using standard protocols everywhere, so
yes,
that you're basically interoperable with any of the cloud service providers, basically.
Yes.
Thanks for the question.
Yeah.
I see a question is here, where is the certificate authority stored in the example? So I mean, in this case, we are using the access token that is generated from Azure, and it is stored at the token itself, as well as the necessary certificate are stored on the secure storage that is provided on the Calypso module. So this is also really important, that it's not just that you have security credentials, but it is also really essential to store it in a secure way. In this case, Calypso provides an encrypted file system where you can store the files, and therein you are.
And when you come from the other side, from the cloud side, you also have the key vaults, for example, in AWS or Azure, where you can store your certificates on the cloud side. So the cloud can identify the device, and device can identify the cloud. So it goes both ways. I have another question.
Yeah, the question coming in: can you recommend a suitable self-hosted cloud software?
Well, self-hosted cloud software, there is like multiple. Well, there is a lot, so maybe we can also answer this per email. I noticed that I will write down the name, and then we're gonna send you the suggestion, because we did a lots of research, and there are like more than 100 different platforms which can be self-hosted or can be hosted in the cloud. And there is like very dependent on the situation, what you actually want to do with the cloud. Do you want to do only the analysis of the data? Do you want to only remote monitoring? Depends really of the usage, but there are like a bunch of those. We ourselves tested more than 20, and there is more than 100 different examples.
The question coming in with the standard for security in the Europe, that is the ETSI EN 645303.
Yes.
Just to repeat this, like I said, it is more or less to do with the consumer IoT devices with basic guidelines and regulations, because it is really hard even for the regulatory bodies to give out a specific standard for security encompassing all these domains from embedded up to the cloud. So these are like the basic guidelines which needs to be implemented, at least to make sure that the device is kind of compliant with the basic security standards. Yeah.
Okay, I saw also the question about the IoT norms. So there is an IoT, I saw ISO IAC norm. This is 30, I think 30141. I mean, I'm not really absolutely sure. We can check online, but there is like a kind of an IoT norm, but there are like they're still not really defined. That the whole IoT world is still not defined. They mostly concentrate on the consumer devices when you need to predefine such values. But generally, you in the industrial area, it's like still in process.
Yeah, I mean, what is a good starting point is I would like to point out towards the IoT Security Foundation. There they have really a good overview of what are all the norms around the world. So you have, for example, a law that was passed in California last year, I think, with respect to IoT devices. Then Australia is coming up with certain standards, as well as the UK. Yeah, and yeah, I mean, there is no worldwide standard as yet, but I think this is more or less inevitable with the growth in IoT devices that we are seeing today.
Okay, so the question about is LoRa with Azure and AWS possible? Well, we never tested, but it should be possible. Like
yeah,
any kind of communication, as soon as you can communicate, you have an IP address, you can do anything with the cloud. So it's possible. We never tested because we have our own modules, and we test with the Wi-Fi, but it is possible. I mean, we tested with Wi-Fi and LTE, narrowband IoT. That's our kind of area of expertise, but LoRaWAN is also possible.
Yes. Maybe we can go through a couple of other questions here.
And if you have enough time now, so maybe 5 more minutes.
5 more minutes, I think.
Oh, that's so many questions.
Yeah.
I can see one. Can we connect other sensors to the system?
Yeah, for sure. That was really the intention of having the FeatherWing as well as the quick interoperability with our system, so that you can really tap into the large ecosystem of Adafruit as well as the quick connectivity. But this is not just limited to quick as well as Adafruit, but you can also connect any SPI, I2C, analog, all kinds of sensors.
As you can see, maybe you can see, I know it's far from the camera, but you can see 6-pin sensor connector. On the other side, you can see the quick connector. And there is also a place for the other quick connectors here, another SPI connector on the other side. So you can have I2C, SPI, and also quick is SparkOne quick format is famous for that. You can do the extension, so you can buy the extension board, and instead of one sensor, you can connect 8 other sensors. So it's like huge ecosystem, and as you can see, the boards are stackable, so you can use also the Adafruit sensors and Adafruit boards. You can connect anything you want. That's why we said it's excellent for prototyping, because you can just connect anything you want from Adafruit or for SparkOne quick format, and then just create your own prototype.
Yeah. Moving on to the next question: is there a web server implemented for Calypso, or do I have this on a host microcontroller? So, I mean, there is a web server available on Calypso for sure. We are currently using this web server to implement our provisioning process, that is basically connecting the Calypso to the local Wi-Fi network. But it is possible to replace these web pages with customized web pages, basically, and use it as a web server for sure. Yeah.
Yeah.
Okay, perfect. I would say if there are any questions left, we will for sure answer them via email afterwards. But for now, thank you very much to both of you. And thank you very much for your attention. And I hope you enjoyed the presentation. The next presentation topic is 27-watt USB Type-C power delivery 3.0 with PPC adapter reference design from our partner from STMicroelectronics. And the session will start at 4 p.m. So yeah, feel free to join. And we hope you enjoyed our Digital Days session, and goodbye.
Thank you.
Bye. Thank you.